So today we're going to take you through a little bit of CAD. So every fabricator's tool is CAD. So what does CAD stand for? That is Computer Aided Design. Hang on a minute, that doesn't quite sound right. Cardboard Aided Design. So you're probably thinking this is not the video you signed up for. Well, you're here now, so you might as well stay. So what are we going to take you through today? If you're a basic in and true fabrication, cardboard is probably your quickest and easiest way to make brackets, tabs, things that you'd either have to pay quite a lot of money to have already made, or you just haven't got the money to have the tools required to do it. We use it a lot, it works quite well. So what we're going to do is I'm going to pass you now over to John, because I've got the blue feet skills of a 2-year-old. So if we head over to the workbench, we'll show you how we use cardboard aided design.
Okay, so following from what Daniel just said, here's an example of what I've made previously, and this is a template of the motor plate bracket that I used on the Mopri. So if you haven't seen it, please go back and look at other videos, and it'll show you that at the front of the car. Now this is too big for Daniel's application, as I'll show you here. So this is the motor plate in situ. This is roughly where Daniel's going to trim along here to make his motor plate more aesthetically pleasing and more importantly fit the car and all the ancillaries etc. coming past. So as you can see, this is way too long, but what he said is he wants the bolt holes to be of a similar size and maintain the rest of the sort of shape there. So all we're going to do then is literally take this and chop it down a bit shorter. So how do I start? To be honest with you, the best thing to do is get yourself some straight tools and get yourself items around your garage or workshop that are circular. And this will help you in drawing, unless you've got a compass of course, drawing your angles. So all I'm going to do is I'm going to look at this. We've marked up on this old template, as you can see here, the lines of basically where our motor plate is going to stop as what Daniel wants. So currently this is 195 mil. So what I can do is I can either transfer this straight across or I can draw it. So what I'm going to do is I'm just going to literally just confirm. See, that's not a straight edge on there. So what I'll do is literally I'm just going to bring it in a bit, draw a new line, something to start from. I'll use my set square and literally just going to true that off. So I've now got a nice corner to start from. So I'm going to go 195 mil in, which is there. So that's now the limits of our bracket. Draw that down, and fingers crossed if I then measure over here, this will be the real test. This should be, give or take, 195 mil. Oh, look at that. I'm about a mil or two out. But hey ho, this part here we're not actually going to use. Right, so Daniel, you said you want the bolt holes the same?
Yep.
Spacing the same. Okay, so we've got our centres then at, I'm going to say that is about 22 mil. So centre at 22 mil in. So I'm just going to mark 22 on there. 22 on there. Now this can get a bit confusing come towards the end, and all I say is if needs be have a rubber handy or do a faint line, because when you start cutting it out using the scissors, once you've cut it you may cut the wrong line. So that hopefully should be, if I line that up, give or take, it's through our centres. That one's actually slightly out, but that one's centre, that one's centre. That means this bracket is marginally out. It's probably that edge there. Right, and then looking at the bolt holes then, we've got them at, let me think, yeah, 75 mil centres. So, you say you want exactly the same?
Well, similar.
Yeah. So do you want the shaped edge, or do you want to go more straighter? Because otherwise I'll have to bring these in if you want them, make them closer. Or I can just go straight down.
No, go straight down.
You want to go straight down? Okay. So what I'll do is I'll use this one as a pickup template then. So you can see the previous lines on here where I've drawn down through my centres. So that should be there. That's the bolt hole we're using. says give or take. Should eventually fit through. Or did I use that one? Nope. Probably was that one. That'll do. What invariably I do is I mark up the holes and then I'll use a drill bit and literally just hand turn it through. As long as I know roughly where, so as long as I know, well, not roughly exactly where the centre is, it's all good. And I suppose that the final caveat to it not being as precise as some people may want is the fact that you'll put this up to the bars coming off the chassis tubes, and you will literally weld this in place and then mark your mid plate or your motor plate holes and then drill the holes in the plate so it will all align whilst on the car. Okay, so that's our bits there, and then what I'll do is I'll take a round object, I'll turn around and say, right, I want something like, what do you want, 10mm land? Yeah. Yeah? Or do you want to go a bit more at 50? No, we'll go 10. Okay, so that point there is 10. 10. What I'm going to do is just transfer a line across. Ideally I want to try and get these as, see that one looks out. My eyes is telling me it's out. But again, you can finesse this up a bit. Those two look right. So go across there just to true it up a bit. And then what you can do then is then whatever you want, draw your circles. The reason we're doing a circle is just so as to, there's an element of A, make it look pretty, but also what we're looking to do is, I mean they're slightly off in this one, but what we're looking to do is remove any sort of stress raising points. So this, when we come to trim it, we'll make it a bit more rounded. It'll look something more like that. And then it's just a case of on these bits working out at what point. So if you want to go from there, we'll look to do that. And literally bring it in, and this then will then come round. So let's trim that a bit more. And then literally always a case of cut it out and then transfer it to a piece of sheet steel. Now I know some people will probably go straight for steel, but I personally like to use the this method purely because it means I can save wasting steel, because steel is very expensive right now. More importantly, it means I can keep going back and back with a couple of pennies worth of cardboard. I bought a massive roll off of eBay. It's about 20 metres worth of cardboard, and I use it to do all the floor templates for the Mopri. It just means I can keep going back, trimming it, getting it so it fits exactly how I want it to be, and then transfer it to steel. It cuts down on all your wastage, and I don't know if we discussed in a previous video, but we've managed to make the whole Capri chassis and the floor, and literally we've got a small green box. There's probably I don't know, 300mm wide, 200mm by 200mm, and probably another 200mm deep of offcuts. So it's kept our wastage to a bare minimum. tricky part of this really will be when you come to cut it out in steel. Or what you can do is, I know Daniel mentioned it previously, is that's basically the shape of our template that Daniel's going to have for his motor plate. If you don't want to cut this out in mild steel, then what you can do is you can make this template and send it to somebody who'll do you a laser cut bracket. And therefore you've got perfect brackets. They'll transfer this template design from a cardboard aid design to computer aid design, and then they'll cut it for you. So it just gives you an option. It gives you an idea, obviously, what you can do with very basic tools. I hope that's helped.